Hey everybody, this is Larry. This is me going with Q4 of the biweekly contest 93. Minimum total cost to make arrays unequal. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So there's no secret. I thought this problem was very hard. It took me an hour, but also to be honest, I think a lot of it was just in the proving. I didn't really. I'm gonna make some things that make me sound really smart, because you're watching this video, and that's why I want to show my process because it's very easy to when you make when someone tells you these observations and the solution, it's very makes everything feels very easy, and you look at the code and it's like, oh, it's 20 lines of the code. Of course it's easy, but really no, it's really hard, and I just want to show that to the viewers at home, and this is why I make these videos this way. If you have question about why sometimes I do things in a little bit odd way, but yeah, so the first observation, and I kind of misread this problem a little bit, in that I thought the cost is the sum of the values. So I kind of, and in the first one, it kind of matched up a little bit. So I kind of was confused. But really, this is a very tricky ad hoc problem. It was disguised in different ways, and I think there are graph theory solutions to this. But the first thing I noticed is that n is 10 to the fifth. And if n is 10 to the fifth, well, you can't really have really expensive n square things, and n log n is okay if your log n is fast and stuff like that, right? So that's point one. So then I was just thinking about and I was thinking about greedy solutions, and I really, and the hard part about greedy solutions, especially during a contest, is the proofs, right? The solution, like, I mean, you can type a lot of them easily, maybe, but it's about the proofs. It's about how to prove it to yourself it's correct. And I really spent a long time on this. Yeah. The first observation I would say is that because the cost of swapping is the sum of the indexes, the first observation to make is that you can always make the 0th index a temporary variable, if you will. What I mean by that is that it doesn't, like, for example, here you could say swap from, okay, let's look at another example. So even here, right, you could say you could swap the values of 2 and 3, but you can actually break it down a little bit more by saying that, you could swap the value, because this costs 5, right? It's 2 plus 3 is equal to 5, but this is exactly the same as swapping the index 2 with the index 0, and then index 3 and index 0, and then index 3, and then index 2 to index 0 again, say, to swap the two values, right? Because of that, let me showcase it a little bit, right? Because of that, though, it means that you don't actually have to worry about the swapping. The swapping is free, so you don't have to do like some, or maybe another way of thinking about it is that you don't have to worry about restricting your swapping to pairs, right? And what I mean by that is, for example, let's say, given this is example 1, and let's just say an easy swap is just do this, right? Well, one way to do it, actually, I don't know if you could do that. Actually, I think you can, but one way to do it is just swap the 5 with the 1. I don't know. But yeah, so you swap the 1 with the 5, so then now 5 is here, and this cost is 5, right? Maybe I did it backwards, but okay, let's try it another way. Yeah, let's swap. I think I swapped it the other way, but the point is still, let's say you swap the 2 and the 1, right? Then now you have 2, 1, 3, 4, 5, and then now you swap the 3 with the 2, right? And then you swap the 4 with the 3. So, but that costs exactly the same as if we had done pairwise, if we just swapped these 2 and these 2 or something like that, right? Because it costs 0 to swap the first element. So that's the key observation. I actually made this observation pretty early, to be honest, but yeah. The second observation that I kind of had a gut feeling for, but I wasn't quite sure and I wasn't able to prove, that I wasn't able to prove for a long time, and I kind of had this gut and I couldn't articulate it and I couldn't try to figure out, was some sort of pigeonhole principle where, you know, because from the first property that we just talked about, it almost doesn't matter where things end up as long as they're not at the same one, right? So then it becomes the idea of, okay, and this is from other problems, I think, but basically, let's say, you know, let's look at just the frequency map, right? So if let's say there is this problem where you have to match, I forget the name of these problems, but you have to match them up such that you always take the max number and then swap it with another number, right? So maybe you have someone like this, and then you just take the 3, and then you take one of the 2, and then you take the 3, and then you take another one of the 2, and then now you just take the 2, and then see if they could all match up, right? In that way. So that's basically the idea that I kind of took inspiration from. And like I said, to be honest, I'm a little bit hand wavy on the proof. I don't quite know how to prove this, but that's basically the idea. But on that problem, there's only one impossible case. The only possible case is if there was a number that is bigger than half. If there's one number that's bigger than half of it, then there's always going to be one number. Or like, you know, if this is 10, it doesn't matter that it's an even number, because then you cannot match it with itself, right? That's basically the idea. And that's when I did the ultimate greedy of, okay, now that we greedily used up all the numbers that are not in the right position, we will try to greedily just swap it with a number that is swappable, basically, right? Because there only could be one number that has more than half the elements, or half of the distinct element, or half of the elements that we have to care to swap. There's only one element that can be more than half, just by definition, or pigeonhole, or whatever you want to say, right? And so we just take that number, and then we go through the entire array once more, and then just put it wherever it can. And wherever we can, we'll go over in a second. So that's basically the solution that I had. Sorry, that's a lot of talking. But basically, let's go over the code, right? So first, I have a counter. I keep track of the counter. Basically I keep track of, for every value, I keep track of the count. If they're the same, that's basically the count of the numbers that we have to move, right? Because if they're not the same, then we don't have to care about it. So we care about that, and then we add the cost because we have to move this no matter what. And you can always move it to 0 and then do that crazy swap thing that we talked about, so we can add the index. Otherwise, and yeah, and of course, if all the numbers are distinct, then the cost is 0, right? Fair enough. And I actually made got a 5-minute penalty based on that, but yeah, but I got a 5-minute penalty because I forgot about this, and then it just froze an error. Should have tested. But yeah, and then I get the max, and this is just basically maxed by the frequency, right? So if the frequency, like, and this is the half part, if the number is less than half, that means that we can do some crazy swapping thing for every number. You can always find a pairing, and you don't have to worry about it, right? Even if it's even if there's an odd number of them, for example, you have 3 numbers, you could do a 3-way swap using just each of the indexes once. So that's basically why. But if the number is bigger than half, which is I wrote in an awkward way, then I have to go through the array one more time, which is that basically, for obvious reasons, I this is how many that we need to swap out, because the other ones will match with the other ones in some way, but then we need to swap them out. And then here, this is just basically, can we swap this, right? If the index is not key, I wrote it in an awkward way. So if they're different, that means that we hadn't considered our original thing. So we haven't swapped it already, and if it is swappable, because if you cannot swap from, or so yeah, you cannot swap it to the key if it's already the same number, because then that's not a good solution. And of course, if the number is already key, then you cannot swap that number to this current position. So that's why there's this condition, and this is just so that we don't add the cost if we don't need it. So yeah, so then subtract by 1, we add the cost, and then that's pretty much it. If we still have numbers left over, then we return -1. Otherwise, we just return the cost, and that's pretty much it. A very greedy solution. And this is actually all in linear time, as you can see, and linear space for the counter. Yeah, linear time, linear space, and that's pretty much all I have for this problem. Yeah. Yeah, that's pretty much all I have for this one. So let me know what you think, and you could watch me solve it live struggling during the problem, during the contest next. Okay, good. How am I doing? 311, yeah, because of the wrong answer. Yeah. I thought it was harder, but apparently people didn't make the mistake I did. Okay, so minimum total cost to make the arrays unequal. You can swap any element. The cost is the sum. Minimum cost such that, okay, so they all have to be different. And 4 people solve it so far. It's and they don't even have to have the same elements. So okay. N is 10 to the 5th, so it's not DP. I should have looked at that first though, but a lot of people got it quickly actually, so I'm pretty okay, maybe not that much, but I still have 5-minute penalty, so that's not good. Can I find this condition? I guess some pigeonhole. But they don't even have to have the same amount of numbers. That's a little tricky. Okay. So we always use the min amount. Do we swap? Okay, you can only swap nums 1. Okay. I actually wasn't sure. Okay. So you always want to use the min amount. I think maybe I talked too much. I have to think a little bit. Okay. So you always want to use the min amount as the swap element. Almost like a reverse cycle thing. Because is that true? Because in this particular case, oh, some of the indexes, not the numbers. Oh, I misread this. Oh, wow. Okay. Well, so you always want to use I mean, they just kind of worded it in a silly way. You can also swap these two and it's the same by commutative. And then swap these two. Okay. Basically, if an array element has to be swapped, then it just has to be swapped, right? So then only one number when an element has to be swapped, it has to be swapped. And it really doesn't matter which one, as long as the same number doesn't get duped more than once. If there's a number left, n is 10 to the 5th, so you can't do n squared stuff, but Oh. Like I said, so that is the minimum cost. Oh, I guess that's the thing, is that you can always use, because now we're using index instead of the number, you can always use the 0 element to as the placeholder, and then it really doesn't matter, right? So okay. Because basically if the wait, what am I doing? Oh, whoops, I forgot this backwards. Maybe something like this. Nope. I think it's something like this though. Basically, we want to check if it's possible. If it's possible, then it's going to be that. If it's not possible, then how do we check if it's not possible? Maybe that's why I got so fast. Can you greedily just do? Is it just pigeonhole? You can use the zeros to swap space. What does that mean? So then you can use 0 to take it to the final price. Okay. So that's going to be the answer no matter what. Because I don't think it makes. But then it. How do you check the impossible case? Is it just greedy? just take the next biggest number. Yeah, why not? I don't know. Let's try it. Yeah, really, just take any number, any slot that is in. I think so. Maybe I'm wrong. The only way that's not possible is with some like pigeonhole thing. But I quite know how to. Maybe I have another idea. No, because then the tree hits. How do I do that part? That's I can't believe I okay. I'm really worried that this doesn't work though. That's why I'm like trying to think. And then this, the reverse sorting thing doesn't work because of whatever. Yeah, let's just try. What am I doing? I don't really have any ideas. I'm gonna get the syntax right. I mean, this would probably be right for this. Maybe not. Okay. What's it called? From sorted container. But I don't even know if this is fast enough, to be honest. That's a lot of removals, and also I'm kind of wrong anyway. Which is good, I suppose. It's better to get it wrong here. So the one, it removes one of the twos, right? Oh, because No, bicep left should be right. Why is this wrong? So for 1 is this, it matches 0, okay. But then the plus 1, why is that not right? Oh, whoops. I just forgot to continue. Okay, well. Oh, this is the same. But okay, what was it? Did I mess up? 1, 2, 3. Maybe I just don't know how to do this one then. These two are the same and this one's the same, so that's 7. But I also need to move this one. Okay, so I think I'm wrong on this, or at least there's more work to be done. Maybe this is right, but I mean, this is the base, so it has to be, but yeah, I see why this is not, because it has to be 1, 2, and then 2, 3, okay. How did I prove that this has to be moved? I guess if they're not, because they're not unique elements, that's why, but how do I know which one needs to be moved? How? Okay, so that's true. This just shows that it's possible, but so basically 2, 2, 3 needs to be moved, but then they need to use one more number that is why not 0, 3? Oh no, it has to be this number, and 1 has a constraint. A lot of people are getting it, but I don't know that I am getting it. I thought that, I think if they're unique values, I think that's why I'm thinking, but so I don't know how to handle the case like this. Basically, this has to be moved, this has to be moved, and this has to be moved, but then this has a constraint that it cannot move. Well, not this one actually. It's just more that, so these two have has to be in at these two can only be in here. Wow, that's hard. Was this 2 and this 1? I think this logic is right, but I don't know how to prove it optimal, or like use that to prove optimality. Maybe, I don't know if this is true, that this is right, because I think there's actually another case, the bias, because this part is not right. Oh sorry, this part is not right, because it could also be equal to x, It's just that I haven't came across it yet. And it probably is wrong too. I don't know. I don't know how to. Okay, let me think about it in graph theory. But it's n to the fifth, so graphs are hard. So we have, in this case, we have to move. I need to write it out. And I think that's my mistake, is that I keep on trying to put everything in my head. Okay, so then now 3 has to go to really anywhere. Oh no, oops, the other way. 1 can, we don't care about 1, the 2. 2 has to go to, there are only 2 places really, and both of them doesn't really matter, but we have to move to 1 is the idea. Huh. So we can't just even, because we definitely want to use 0 as the swap as possible, and we still can. So that means that everyone would go to the, even the 2. We can definitely do that. We just need to figure out where everyone wants to go. Right. So if there's a thing, then that's fine. But then now we have to figure out, how do we know how to get the 1 out of its forced position? And the way that I wrote it this way here, even if it's right, it's not going to give it to me. I mean, people took some people got it pretty quickly, actually. Good for them. I just have no idea. I mean, that's the minimum cost, but there's an additional cost. I think the additional cost is only 1 more element. Well, that 1 more element times, no, that's not true. We could use the 0 as a swap, so there's only really 1 extra element possible. And that is, how do we even get that one? And we do it in a greedy way. So let's say we have 1 and then the 2. You have to move it. Okay, so just grab a number. How do we even know where we grabbed the 3 from? Maybe I just don't know this one. So okay, so let's say we do greedy, right? The 2 we grab the 3 because it's the same. We swap those 2, and then now the next 2, what happens? The 2, well, we can grab the other 2, so we have to look at the first index in which, yeah. Okay. Basically, you want to grab a number. Maybe it's this? I don't know. And now we can just should there only be one element left? I can't prove it to myself that at most there'll be one case, and I guess that's not true because you could just add more 2s, and then just like kind of 5, 6 or something. It doesn't really matter, and it still just takes it from that. I don't know how to solve this. Huh. Can we sort it? What happens when we sort it? Well, we sort it here, that's fine. We sort it here, what do we get? 1, 2, 2, 2, 3, 1, 2, 2, 3, 3. After we sort it, well, I mean, the sorting doesn't differentiate between here and here. So I don't think sorting it does anything. We can always do that, but then how do we get the one where, so there only should be one set of numbers where otherwise it would just matched up. Okay, fine. I have 40 minutes. I could figure this out. Okay, so in that case, I don't, yeah, I guess I do need index. Okay, I think maybe I got the idea. That's tough though. Okay, I think I have the idea. Let's just do it this way. I don't know if that's good, but so same take the expensive first, because why not? I guess it doesn't really matter which one, but I just take this out for now because I get confused. So this is pop left. This isn't. Oh wait, no, this is pop. It's. Okay, then. Okay, so this should give me the same wrong answer as before. Okay, that's actually not great because I expected this one to be good, but it doesn't. Okay, well, let's just print out keys. I think it just has to be 1, which is fine. Oh, the 3 left because we matched the 5 and the 1. Sorted in a weird way. of the... And this is 1, so then why is this not? Am I messing up? Why is it not sorting by this thing? Oh, I guess it is, it doesn't matter. It's just that now we're... Okay. And then now... Okay. We're gonna... The length of keys is greater than 0, so that means if it's 0 to 1. T, then cross. Yeah, well. Oh, I see, because this thinks that... Oh, it has to be that this index is the same because we haven't moved it yet. Or it's not the same because we haven't moved it yet. Because that wasn't in the consideration. One, okay. Still not really right though. I was hoping. -1, why? Because it's an 8. Oh, because the way that I did it, I swapped the 1 and the 5 and the 2 and the 4. Because I swapped it. When we get this one. Exactly. So this one has 1 left over, but doesn't have to be. So my assumption was wrong on this one. Greedy is hard. It's almost like a weird bipartite matching, but its n is equal to 5th, so it's so big. I don't even know if this is right, to be honest. I don't know. Maybe this way of doing is not right either. Because I do. I just don't know how to do this one. Really, this case is the case that I don't know how to do. Like this one. Is there a better answer? Let's see. I mean, not a better answer, but a different way of interpreting the answer. Like the 3 goes to here, so then now it's 3, 2. And then now the 2 goes to the 1, so it's 1, 2, and then now you have the 2. 2, 3. How do you get that? And there could be more of these, right? Where I just don't consider it. It's not even n over 2 because you only have 2 n. I guess in this case you have 3 n's actually, 3 2's, but I thought I could do something creative, but I don't. Well, with, yeah, I don't know how to do this. Like, I'm seeing the cases in my head. People are so smart. It is definitely a hard one. thought that it doesn't matter which one you match, but I guess that's not true. I'm pointing to this one because you could have a 3 cycle. And this one you have to create one out of nowhere, so that's even trickier. Basically, I just get the next number or next index that I'm available. But if this one's this one, I don't even know. This is just, I think this is okay for checking whether it's possible, but not for minimal costs. I don't know how to do it in such a way that okay, so then it basically looks at these 3 and then it goes, I need one more thing. And one more thing has to be. I don't know, 22 minutes. I don't know how to do it. A lot of people are getting it now, but how do I figure out how to get this just a good number? This and this swap, this and this. And also, I'm only, the other album I had only paired them up, but really, That's what I was kind of doing before, right? Well, the way that I was doing was matching them. Just try to find that they have a place to go in the lonely world. I think there's only really this one case though. I can't really quantify it. Basically. All the other things don't matter. It's only really the most unique one. It's almost like that heap problem. Let's see. I don't know. So maybe I should match it this way. Maybe what I should do is do that now. Does that work? I don't know anymore. Okay, so then now. And then now maybe something like well, this is really weird anyway, but why is this only one? Shouldn't this be two? If I sort it by whoops. So I have to max. Okay. Is greater than T. Needed is equal to cow minus t minus t minus cow minus t. I thought I had that condition somewhere actually. I don't know, maybe I took it out. But also that is different because otherwise we would have considered it. this is right though, but what else am I doing? Okay, well, I mean, there's no way for me to, you know, now at least I have a wrong answer to play with. Is this not the... Oh, did I misunderstand? I mean, this is the input. That's why I'm a little bit sad about that, but... because that's not a new... Like, getting a wrong answer is fine, but... Wait, what? Why is this the case? Two... Why? This is just one. Three, two... Oh, this is the last number. Okay, I got confused with which problem we're doing. Okay, fine. We don't need to do that then. That's true. That's 7. Oh, because then it tries to do the first one, but then and yeah, because you can't swap that way. Okay, well, give it YOLO. Come on, man. Alright, now I'm just making really silly mistakes on the rushing YOLO, but I guess that's fine. I mean, it's better than nothing at this point, but still a little bit sad on this point. I mean, I think the 2 wrong answers were a little bit silly for me, to be honest. Yeah, should have gotten it earlier, but so many penalties. The 2 wrong answers were very silly though. I think one of the wrong answers, I mean, one of them was the input, so I think yeah. Also, it kind of the thing that annoys me afterwards a little bit is that I actually did have this idea throughout, but I just didn't think I just couldn't prove it, and because I couldn't prove it, I just didn't work on it, and then at the end, I think I just kind of, I was just like, well, you know. I think at the end I was just like, I have no more other ideas, so might as well try it. But that's kind of but that's kind of, yeah, I don't know. Probably could have done it a little bit better, is what I'm saying. And of course the other one, it was just silly. But I mean, yeah, I don't know. Just a small rewrite. Okay. Also just checking about the time. I guess the time's okay. This makes it much faster, but yeah, that's pretty much all I have for this contest. I mean, I think I did respectably. Not great, but I don't know. I think that's what happens sometimes at practice, is that if you don't practice your intuitions, you can't really prove. And I really spent most of that contest proving to myself. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and this video, this contest, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.